Hello, geometry students. Today we're going to learn a little bit more about lengths of segments and chords and secants and radii and diameters when those things occur inside and or around a circle. So we are going to talk about a couple different rules. Now in this video, I'm not going to prove to you where these rules come from. We're just going to talk about the rules and practice them. But I will say that all of these rules come from the fact that if you were to create some triangles based on these segments, you would get similar triangles, and those similar triangles create proportional sides. But again, I'm not going to prove that in this video, so this video is just about the rules and how to use them. So the first rule that I need you to learn is about segments intersecting inside the circle. So when I have segments that are completely inside a circle like this, you want to remember that those things are called chords. And if I have these two intersecting chords right here, they split each other up into two parts apiece. And the rule is that the product of the partial segment lengths of intersecting chords are equal. In other words, A times B equals C times D. That's it. So if we come down here and do a little bit of practice, oh look, I have two chords. This one happens to also be a diameter, but that doesn't change the rule. 4.8 times x equals 7 times 7. That's it. So then you're just going to take your calculator and say 4.8x equals 49. Divide by 4.8. And if we put that in the calculator, you get about 10.2. We'll round to the nearest tenth. And that's it. Find the value of y. Same thing. Here's two other chords. Y times 5 equals 4 times 9. So 5y is 36. Divide by 5, and you'll get y equals 7.2. That's it. Rule 1, done. Now, what if instead of I have two crissy-crossy chords, I have two things that intersect outside? What if I have two secants? And if you remember, secants are like a chord that keeps going. So if I have two secants that intersect outside the circle at some external point, the product of the outside part of the segment multiplied by the whole segment is going to be equal for each secant. So if I was going to look at this top line, or top segment, I should say, outside is W, whole is W plus X. So W times W plus X is outside times whole. And now we're going to do the same thing for the bottom part. Outside, Y, times whole, Y plus Z. So the rule is outside times whole equals outside times whole. Well, what if instead of two secants, I had a secant and a tangent? Those can still intersect outside. So here's a tangent. Here's a secant. The rule for that is slightly different. What you want to do is you want to square the length of the tangent and then still do outside times whole for the secant. So the rule is the tangent piece gets squared, t squared, equals outside times whole for the secant. So tangent squared equals outside times whole. All right. Now, one other thing I want to say about this is it's still technically outside times whole equals outside times whole, but for the tangent, for this piece right here, when I do outside times whole, the outside is t. The whole is also t. So t squared is really doing outside times whole. All right. Now, what if I got two secants? I got a tangent and a secant. What if it's two tangents? Well, that one's really easy. When you have two tangents, they're always going to be equal. This equals that. Ta-da! Two tangents drawn from the same external point are congruent. So I know that AB is congruent to AC. And now we'll do some practice. All right, find the value of x. This is a secant. That's a secant. So we are going to do outside times whole here. All right, so for the top part, the outside is 14. The whole would be 14 plus 20. The outside is 16. The whole would be 16 plus x. And now I just solve for x. Well, let's see. This is going to be 14 times 34 equals, well, here, you know what? I think I'm going to distribute this 16. So 16 times 16 is 256 plus 16x. And now we want to make sure we've got a calculator nearby. So 14 times 34 is 476 equals 256 plus 16x. Subtract. And we get 220 equals 16x. And then divide. And we get x equals 13.75. Outside times whole equals outside times whole. Now, what if your outsides, if one of them's a tangent? That's okay. You just square that thing. So over here, we have that rule of tangent squared equals outside times whole. So then I have z squared equals 8 times 24. And let's see, 8 times 24 is 192. And then if we square root that, I get 13.856. So let's call this 13.9. And there you go. Okay, so now there's a little bit of mixed practice here with the stuff that we've just been talking about. Okay, so we have what looks like about a page and a half of mixed practice. So I want you to try these two down at the bottom, pause the video for a second, and try to do these two on your own and then unpause it. Okay, ready? Pause. Okay, hopefully you paused it. So on this one, we have two intersecting chords. So it's part times part, which is the x times 15, equals the other part times part. So I have 15x equals 240. And then if I divide by 15, I get 16. Number 2, these intersect outside. So outside times whole equals outside times whole. So outside times whole equals outside times whole. Oh, I'm going to have a quadratic. All right. So if you struggle with the quadratic, pay attention here. So I've got 6 times 14 equals y squared plus 5y. So 6 times 14 is going to be 84. And now I'm realizing I have a y squared and a y. So to solve this quadratic, what we need to do is set it equal to 0. And then we're going to try to factor. So y squared plus 5y minus 84. Now I need two numbers that have a product of 84 and a difference of 5. So 1 times 84, not going to do it. 2 times 42, no. 3 times 28, nope. 4 times 21, nope. 5 doesn't go in. 6 times 14, nope, that's not going to do it. 7 times 12. I finally found it. 7 times 12. You could have also done that in your calculator. But one thing I think is also a great way to do it is just go through the factors on your own. So 84 is 7 times 12. So I'm going to have y squared plus 7y minus 12y minus 84. And then you can do factoring by grouping. Or even shorter than that, if your lead coefficient is 1, when you find two things that multiply to negative 84 and add to 5, you can create those inside of your factors. So positive 7 minus 12 is going to get me a negative 5y, so that's not going to work. So I'm going to change this to a -7 and a +12. 12 minus 7 is the +5 I need. When you factor to solve, you set them both equal to 0. So I'm going to add 7 and get y equals 7. Subtract 12. Y equals -12. But y can't be -12. It's a segment length. So 7 is the one and only answer. Whew! Lot going on there. Okay. If we turn the page, we've got 2 more here. The good news is no quadratics, so let's try 2 more at the top. So if you would, kindly pause your video and then come back and I will go over it with you. Ready? Pause. Really do it. Pause. If you're still listening, you're supposed to be paused. Pause. Pause. Try it yourself. Try it yourself. Try it yourself. Okay. Hopefully you paused. So if we come here, I've got 2 intersecting inside. So part times part equals part times part. So I have x minus 9 times 24 equals x minus 5 times 21. And then I'm going to distribute. So I have 24x minus 216, I believe. Yep. And then I'm going to distribute here and get 21x minus 105. Okay. Now I need to solve for x, so I'm going to subtract 21x from both sides and get 3x minus 216 equals 105. Pardon me, negative 105. I almost lost that negative there. Then I'm going to add 216. Negative 105 plus 216 is going to give me 3x equals 111. And then if I divide by 3, I get x is 37. And I'm now just realizing that there's a typo. This should say find the value of x, not y. My apologies. Oh, so 4 is a little bit tricky, and hopefully you paused. If you paused here with number 4, if we look at this thing, there's a lot going on. I'm missing A and B, and I've got some stuff inside and some stuff outside. That perpendicular, whew, there's a lot that you have to think through here. So the first thing I'm noticing is this perpendicular. And if I have a radius or a diameter that's perpendicular to a chord, I know the chord gets cut in half. So this other side would also be A. So if I were to like cover up with my hand all of this stuff, that's all inside the circle. So I could say A times A equals 4 times B. Okay, well that means I can't solve for that unless I know either A or B. So let me unscribble this outside stuff and say, well, if I have stuff that goes on the outside, it's outside times whole equals outside times whole. The 12 is a tangent, so that would be the tangent squared equals the outside times the whole thing, which would be 8 plus A plus A or 8 plus 2A. That I can solve. So I have 144 equals 8 times 8 plus 2A. And then if I distribute that 8, I have 144 equals 64 plus 16A. I'm going to subtract 64, and then I'll get what? 80 equals 16A. And then I'm going to divide by 16. And if I do 80 divided by 16, I believe I know what I'll get, and I do. It's 5. So now that I know A is 5, I can say 5 times 5 equals 4 times B. And to get B equals 6 1/4. Okay. And now this last one, what do I do here? They go outside. But they're both outside. Those are tangents. So they have to be congruent. So all I got to do here is 4x minus 9 equals 15, and then solve for x. And I get x equals 6. Done. That's it. Well, that's the whole video, folks. So now that we're at the end of the video, let's really quick take a recap. If you have a circle and two chords intersect inside of it, it's part times part equals part times part. If you have a circle and stuff goes outside of it, the rule is outside times whole equals outside times whole. If things that go and duck on the outside happen to be tangents, if they're both tangents, easy peasy, they're the same. And if only one of them is a tangent, you still do outside times whole equals the tangent squared. Just rules. I am done with that. I hope you're having a great day. You continue to have a great day, and I will see some of you soon.